Hello students, in today's session we are going to discuss the concept of pure rolling on an inclined plane. In the last class we have already seen what is the kinetic energy for a rolling body, and we got the answer as half mv square into 1 plus k square by r square, that we have already derived also. Now in today's class we are going to discuss the concept of pure rolling on an inclined plane. In this, what we are going to discuss here, let us first of all, you should understand what we are going to discuss in this session. We are going to discuss the three physical quantities. The first one, the velocity, the second one, acceleration, and the third one is the time. So let us discuss one by one what the velocity, what the acceleration, and what the time we are going to discuss under this situation of pure rolling on an inclined plane. So for that, I consider one inclined plane. This is an inclined plane of inclination theta. Height of this inclined plane is h, and the length of the inclined plane, I take it as L. The length of the inclined plane, L. Now, what I do, for at the topmost point of this inclined plane, here I consider one rolling object or a rolling body, and I keep it. Now, what happens, students? This rolling body rolls down, and when it reaches the bottom of the inclined plane, it will acquire some velocity. And what is that velocity? Velocity means it is due to both translational motion as well as rotational motion, because it is going to move like this. Okay, so here I can say which type of energy associated with this. Here I say the rolling kinetic energy. And here, what type of energy do we have at the top when you about to leave this object on the inclined plane? Here you will be having purely potential energy. So students, what is our aim in this topic? In this topic, we are going to discuss like velocity. When you leave this, when you leave it, this will roll, come down, and it will move with certain velocity. That velocity we are finding in this situation. How much is the velocity that is gained by this rolling object after covering this inclined plane? The first one we are going to discuss about the velocity. How much is the velocity with which it is going to reach the bottom of the inclined plane? Now students, pay attention. The body is coming, the rolling body is coming down the inclined plane. So 100% what we observe is the velocity of that particular rolling object increases. That means there will be some acceleration with which this object is going to come down. I repeat once again, when the body starts coming down by rolling process, what we observe is the velocity of the object continuously increases, and there we can say that the acceleration is there in the body. That means the body is going to move down with some acceleration. That is also we are going to calculate under this session. Next, this object will take some time. This object will take some time to come down the inclined plane. So how much is the time taken by that object to come down the inclined plane? That also we are going to discuss under this topic. So one by one we are going to discuss. The first one what we are going to discuss here is the velocity. Velocity with which it is going to come down. So students, to know the velocity with which it is going to come down, what I can do here is I say I can apply here the law of conservation of energy. So what the law of conservation of energy says: energy can neither be created nor be destroyed. Okay, one part of the law of conservation of energy. But the second part of the law of conservation of energy, what it says that the energy can be converted from one form to another form. So I apply here the law of conservation of energy, and I say that when the body is at the highest point, it is having the potential energy, and when it is coming down and it has reached the bottom of the inclined plane, it has gained the rolling kinetic energy. So therefore, according to the law of conservation of, I'll write here, according to law of conservation of energy, what I do here is potential energy. Suppose this is the point A and this is the point B. So what I can say, the potential energy at A will be equal to rolling kinetic energy at B. Don't say just rotational because the body is rolling, right? Rolling, yesterday in the last class, I have already explained what is rolling. Rolling is the combination of translatory motion as well as rotational motion. So that gives us the rolling kinetic energy at the point B. Now my question is, what is the potential energy for this object which is at a height h? You can see clearly the height of this object is h. So therefore we say the potential energy is mgh. And here kinetic energy, that is rolling kinetic energy, and we have already derived the formula for rolling kinetic energy. It was half mv square 1 plus k square by r square, right? So this m and this m get cancelled. Clearly you can see that the velocity, the expression, whatever we are going to get, it is independent of the mass of the object because the mass term is getting cancelled here. So what I do here, I just cross multiplies 2gh. 2gh is equal to v square into 1 plus k square by r square. Now student, this is v square is equals to 2gh by 1 plus k square by r square, and we are getting the expression for the velocity as 2gh by 1 plus k square by r square. So this is the velocity with which the body reaches the bottom of the inclined plane, and this is a rolling velocity, I can say. From the formula, I can say that this velocity, we don't have any mass term here, right? Because the mass term is getting cancelled here. So we can say that the velocity of the rolling body is independent of the mass of the body. Whether you are taking a huge object or a small object, they are going to move with the same velocity. So therefore, I say the first point, velocity, the first point I am writing, velocity is independent of first one, mass of rolling body. Mass of the rolling body, it is independent of the mass of the rolling body. And the second one, this is independent of the radius also. In what way the radius? Because we are getting the term r square. This is r square, right? K square by r square we are getting. So this, it is, we are getting in the formula r, and I'm saying that it is independent of the radius. On what basis? See, try to understand. When r increases, radius of gyration also increases. The ratio of k square by r square always remains constant. So therefore, what I can say, it is independent of the mass of the rolling body as well as the radius of the rolling body. So I hope you have understood how to get the expression for the velocity of the rolling object on an inclined plane. Now students, we are going to move for the next physical quantity, what we are going to discuss in this session. As we have already seen what is the expression for the velocity, and we have derived the expression for velocity as under root of 2gh by 1 plus k square by r square. As I said, when the object is coming down, it is observed that the velocity increases. That means the object is going to move down the inclined plane with some acceleration. So that acceleration we are going to see how much. So here what I do, pay attention, at any instant, I'm taking, this is what you call the object, the length here it is L. You know, the weight acts downwards. थोड़ा सा आप यहाँ पे ये देखना है बेटा, weight acts downwards, mg, and this can be resolved into two components. Already we have seen, this is mg cos theta, and this is what, mg sin theta. Mg cos theta and mg sin theta. Here the frictional force, that is what you call it as the static frictional force, because the point of contact, यहाँ पे the very important thing, the body is moving and still we are considering the static frictional force. The reason here is the rolling body. The rolling body, if you go for a rolling body, the velocity of the point of contact of the rolling body and the surface on which it rolls, it is always zero. And we have seen under the concept of rolling motion, topmost velocity is 2v and bottommost velocity it is 0. So we consider this point is at rest and we speak about the static frictional force. So what is the reason for this object to have an acceleration? That I am showing you. It is because of the net force, that is mg sin theta and fs. So how is the net force acting on this? It is mg sine theta, and this is what minus Fs, because that is acting upward. So because of the net force, this object will going to move down with some acceleration that we are calculating. So before going to the acceleration, let us see what is the relationship that exists between the length of the inclined plane and the height of the inclined plane. So for that, what I do, I take, this is theta, no? So here, try to understand sine theta. What is sine theta? It is opposite by hypotenuse. So it is h by L. So here, what is h? H is L sine theta. So this is the relationship that exists between h, that is the height of the inclined plane, L, that is length of the inclined plane. Now come to the equation. Already you know, students, one relation is there in kinematics, that is v square minus u square is equals to 2as. देखिए बेटा, यहाँ पे हम, we know that this is v square minus u square is equals to 2as. This is the final velocity, and already the final velocity we have derived. अच्छे से देखना है बेटे. This is what? 2gh by 1 plus k square by r square. Students, अच्छे से देखिए बेटा. This is the velocity, final velocity, what I am considering under this situation. So here it's a square, right? This is a square, v square, this minus u square. What is the initial velocity here? It is 0. That is equal to 2. And this is a, that we need to calculate a, and this is s. So what is s? Here you can write s as the length of the inclined plane. You can see the distance traveled is itself is the length of the inclined plane. So therefore here I will write here it as L. So this and this get cancelled. So 2gh by 1 plus k square by r square is equal to, this is what? 2al. Now students, what I do here is just this 2 and 2 get cancelled. This is g, and in place of h I can write L sine theta. L sine theta by 1 plus k square by r square is equals to a into L. Now if you cancel this L also, so what the formula I am getting for acceleration? So acceleration is equal to the final answer, g sine theta by 1 plus k square by r square. You can see clearly a is equals to, this is L getting cancelled. So a is equals to, this is g sine theta by 1 plus k square by r square. Hope you have understood how we are getting the expression for acceleration, and you have to remember the formula for this. Next, we go for the third physical quantity, that is the time. You know, students, the body is released from rest. Because of the net force, it is coming down with some acceleration and reaches the bottom of the inclined plane. So to reach the bottom of the inclined plane, it takes some time. So how much that time is, that we also, the question can be framed on that. So how to calculate the time? This is the time what I am calculating. Now, this is the expression what I have done. This expression is for acceleration. This is for acceleration. And this we have derived here. Now, we are going for time. So for this, you know, v is equals to u plus at. What is v? We have seen v is under root of 2gh by 1 plus k square by r square, that is equal to, this is initial velocity 0 plus, what is a? A is g sine theta by 1 plus k square by r square. G sine theta by 1 plus k square by r square into t. Now from this, what we can write, this is what? 2gh by 1 plus k square by r square is equals to, this is g sine theta by 1 plus k square by r square into t. Now students, this t I need to calculate, means I have to take the whole term in the denominator here, that you can do it. So it is what? Under root of 2gh by 1 plus k square by r square. This is in the numerator. Denominator में ये पूरा जाएगा बेटा. This is g sine theta by 1 plus k square by r square. Here you can further simplify also by taking, by cancelling 1 plus k square root times, and this also root is there, that you can cancel. But I don't suggest you to cancel and go for the formula, what I can say, that which you cannot remember. So here the process I have shown you, if this process, if you are understanding, and you can do it by yourself, just the values will be given, substitute and get the answer for the time, how much the rolling body takes to come down the inclined plane. I hope you have understood how we have derived the acceleration for the rolling object on the inclined plane and how much time it takes to come down from the top to the bottom of the inclined plane. Students, we have seen pure rolling on an inclined plane. So let us do some problems on the same concept. The first problem on the board, you can see here a solid sphere is there. It's rolling down an inclined plane without slipping. Height 7 meter. Calculate the, without slipping, the height of the inclined plane is 7 meter. Calculate the maximum velocity with which it will reach the bottom of the plane. So we have to calculate the velocity. So here, before going for the velocity, you can see clearly the height of the inclined plane, it is 7 meter, and the G value, we have to take it as 10. And one more thing, what we have to be careful, here the solid sphere is mentioned. You can see clearly the rolling object is a solid sphere, So therefore, what I do here is, you know, the concept of velocity, that's now we have seen, it is what, under root of 2gh by 1 plus k square by r square. So what is this 2? This is 2. G is how much? As per the question, it is 10. H value, you can see it is 7 meter by 1 plus, pay attention, this k square by r square. So what the value you are going to consider for k square by r square? It's very simple. You can see that is a solid sphere, So for solid sphere, I'll write for solid sphere, what we are getting, you know, the moment of inertia, the formula for moment of inertia for solid sphere, 2 by 5 mr square. And you know student, general formula for moment of inertia in terms of radius of gyration क्या है बेटा, यहाँ पे mk square is equals to 2 by 5 mr square होता है. ठीक है, m और m कैंसिल, दोनों भी कैंसिल हो जाएगा, m and m. So what we are getting, अच्छे से देखिए, this is what k square, इसको नीचे लीजिए, by r square. The answer is how much? 2 by 5. So this is the process what I have shown you. मैं just आपको एक process बताया हूं कैसा वैल्यू निकालेंगे आप k square by r square की. लेकिन बेटा while doing the problems in competitive level, आप इतना सब करने की जरूरत नहीं है. You need not to do all this thing. यहाँ पे जो नंबर होता है ना बेटा, this is 2 by 5. यही नंबर होता है the value of k square by r square as 2 by 5. आप इतना सब करने की जरूरत नहीं है. You have to save time. ठीक है, तो आपके जो नंबर पहले अपीयर होता है, दैट इज द वैल्यू फॉर के स्क्वायर बाई आर स्क्वायर फॉर दैट पर्टिकुलर रोलिंग ऑब्जेक्ट. अगर मैं आपको बोलता हूं द फॉर हॉलो स्फीयर, व्हाट इज द वैल्यू फॉर हॉलो स्फीयर फॉर के स्क्वायर बाई आर स्क्वायर, कितनी वैल्यू होंगी? तो आप सॉल्व करने की जरूरत नहीं है बेटा, जस्ट आप सोचेंगे भाई हाउ मच इट इज, लाइक 2 by 3 mr स्क्वायर फॉर हॉलो स्फीयर 2 by 3, तो आपको आंसर आने वाला है के स्क्वायर बाई आर स्क्वायर की वैल्यू होगी आपको 2 by 3. आई होप यू हैव अंडरस्टूड दैट. ठीक है, चलिए आइए, अब यहाँ पे मैं ये वैल्यू के स्क्वायर बाई आर स्क्वायर की वैल्यू यहाँ पे वॉट एवर इज देयर आई विल कीप, यहाँ पे रखता हूं मैं. दिस इज लाइक दिस. नाउ दिस इज 2 into 10 into 7 divided by, you can see clearly, I take the LCM here, it is 5. This is 5 into 1, 5 plus 2, this is 7. Now students, this 7 and 7 gets cancelled. This 5 goes up and gets multiplied here. So it is what, 5 into 2 into 10, that gives us 100, and the root 100, it is 10 meters per second. So the velocity with which the rolling object going to reach the bottom of the inclined plane is 10 meters per second. Students, we move to the next problem. The next problem here you can see on the board. जो next problem है देखिए बेटा यहाँ पे, what we are getting here, when a body is under a pure rolling, it's a pure rolling, the fraction of its total kinetic energy which is purely rotational is 2 by 5. Identify the body. It's a very important question, very important model. You can see clearly the fraction of the total kinetic energy is purely rotational is how much? 2 by 5. We have to identify which body it is, whether it is like what I can say rolling object is a ring है या sphere है या solid cylinder है, hollow cylinder है, which type of object it is, that we are going to calculate. अब यहाँ पे हम identify करते हैं बेटा यहाँ पे. ठीक है, चलिए. So as per the question, you can see clearly total kinetic energy, which is purely rotational. That means rotational kinetic energy divided by, this is what total kinetic energy, that gives us the answer is how much? 2 by 5. This is 2 by 5. Okay, this is 2 by 5. Now what I do here is rotational kinetic energy, the formula for that, it is half I omega square divided by, this is total kinetic energy. What is this total kinetic energy? Total kinetic energy, you know, it is half mv square 1 plus k square by r square. So the value for this, they have mentioned it as 2 by 5. I hope you have understood. This expression I have written for total for rotational energy, and this is for total kinetic energy, that is a rolling part. So this I, this half get cancelled. This I can write it as mk square, and this omega we can write it as v by r, v by r. So therefore what I do, this is v square by r square by what, this is mv square into 1 plus k square by r square, and that is equals to 2 by 5. Now this m get cancelled, v square get cancelled. So what remains, students? K square by r square divided by 1 plus k square by r square is equals to 2 by 5. Now just you cross multiply it. If I cross multiply this, I am going to get 5 times of k square by r square, and this term is to be multiplied with 2. So let us see what we are getting here. So it is 5 times k square by r square, and that is equal to, this is 2 times, this 2 times 1 plus k square by r square. Now this is 5 k square by r square, and that is equals to 2 plus 2 into this 2 k square by r square. If I take this term here, what I am getting, 5 k square by r square, take this term this side, so minus 2 k square by r square is equals to 2. So how much this value, if I take the LCM as r square, so if I take the LCM as r square, this is 5k square minus 2k square, that is 3k square. तो यहाँ पे लिखेंगे बेटा हम 3k square, that is equals to 2. So what is the value for k square by r square? That is equals to 2 by 3. So k square by r square की वैल्यू मेरे को मिल गई बेटा, कितना मिली है देखिए, 2 by 3. So from this k square by r square हम identify कर सकते हैं what is the value, what is the object, what is the rolling object here. तो आपको पता है the formula for hollow sphere, moment of inertia for hollow sphere. If you remember, for hollow sphere we write the moment of inertia as 2 by 3 mr square, and here also we are getting 2 by 3. So that identifies itself कि भाई that is a hollow sphere. लेकिन अगर आप मेरे से proof पूछते हैं how you are identifying that, थोड़ा सा एक step आगे बढ़ेंगे हम. So this can be written as mk square, that is 2 by 3 mr square. So this m get cancelled. So what is the value for k square by r square? So it is 2 by 3. So for hollow sphere, the value for k square by r square, it is 2 by 3. I hope you have understood the question along with the solution. Students, next we move to the next problem. So what is that next problem? Here you can see a thin uniform ring is rolling down an inclined plane of inclination 30 degree without slipping. The linear acceleration along the inclined plane is, here the acceleration is asked, how much is the acceleration? And you know the acceleration formula, g sine theta, just now we have derived g sine theta by 1 plus it is k square by r square. G sine theta by 1 plus k square by r square. Now under this, what is the value for g? G it is, we take it as for 10, and sine theta angle is also given as 30 degrees. So let us move. This is 10 and this is sine theta. So I will write sine 30 by 1 plus k square by r square. So to get the value for k square by r square, what we are taking, that is it is underlined already, that is a circular ring. It is a ring. So therefore what I do, for ring, you know the moment of inertia, it is mr square, and if I take this I is mk square, that is equals to mr square. This is the fixed formula for moment of inertia in terms of radius of gyration. So get cancelled, k square by r square, it is equals to 1. I'm taking this r square here, so k square by r square कितना होगा, देखिए यहाँ पे 1 होगा बेटा. तो अब यहाँ पे मैं k square by r square की वैल्यू यहाँ पे 1 लेता हूँ. So this is what 10. You can see it is 10 sin 30. It is 1 by 2 by this is 2. So what happens, 2 1 times, 2 5 times, फिर हम 2 से हम इसको कैंसिल करेंगे बेटा, तो 2.5 होता है ये. So this is 2.5 meter per square second is the value for acceleration, that is the linear acceleration down the inclined plane.